Hello, my name is Andrew O'Brien, and today I will be solving the June 2016 Common Core Geometry Regents exam. So I don't need much introduction, let's just begin. So question 1. A student has a rectangular postcard that he folds in half lengthwise. Next, he rotates it continuously about the folded edge. Which three-dimensional object below is generated by this rotation? So this question is fairly easy. Just imagine physically folding a postcard on its long end, and you'll get something that looks like this. Now, if you rotate this about the folded edge, that means rotating it like this. And if you extrapolate the path of motion across the entire duration of motion, you will get a shape that is a cylinder. Sorry, that drawing's not the best. It's difficult to do on a mouse, but you can very clearly see that the answer to this is 3. Okay, question 2. A 3-inch line segment is dilated by a scale factor of 6 and centered at its midpoint. What is the length of its image? So for this one, you should know that the property of dilation is that the length of any line segment that's dilated is equivalent to its original length times the dilation factor. In this case, since the scale factor is 6 and it's a 3-inch line segment, it's just basic multiplication. 6 inches, 3 inches times the dilation factor of 6 will get you 18 inches. Therefore, the answer to question 2 is 4. Question 3. Kevin's work for deriving the equation of a circle is shown below. In what step did he make an error in his work? So this question is obviously theoretical. You just have to point out the error that Kevin makes. And the error actually occurs in step 2. More particularly, it happens with this operation. If you have an algebraic equation, then you have to perform the same operation to both sides. In this case, Kevin's mistake is that he adds 4 to one side and subtracts 4 from another. If Kevin had added 4 or subtracted 4 to both sides, then in that case, the mathematics would be valid. But because he adds 4 to one side and subtracts 4 from another, that means he's made an error. So therefore, the answer is choice 2, step 2. Which transformation of OA would result in an image parallel to line segment OA? This is question 4. So if it has to be parallel, then that means that the line cannot be rotated by all possible angles. If it were rotated 180 degrees or even 360 degrees, that would preserve the parallelness of line segment OA. So let's see how these choices would tie into this question. Choice 1, a translation of 2 units down. We could represent that with a line like this. You can think of a physical arrow going here. This represents the translation. Choice 2, a reflection over the x-axis. If you reflected it over the x-axis, then you would get another line. In this case, you can think of the x-axis like a mirror. Whoops. And this is the case that these lines are obviously not parallel. Now, choice 3, a reflection over the y-axis. Imagine the y-axis like a mirror, and the reflection would look like that. Once again, this would not be parallel, as is very obviously visible. And choice 4, a clockwise rotation of 90 degrees about the origin. Now, this might possibly be the case. However, you can visually see that this line does not perfectly bisect the x and y axis. This does not look like it's 45 degrees in measure. And you can tell because this line visually has a higher rise than it does a run. And if you were to rotate this 90 degrees about the x-axis, about the origin, in turn, you would get a line that looks like this, where this angle would be 90 degrees. And whereas the original line had a greater rise in y than a run in x, this line has a greater run in x than a rise in y. So therefore, the image is not parallel. If it were 180 degrees, then it would retain its parallelness, but because it's only 90 degrees, we can safely eliminate that choice. So the only choice that makes sense here is choice 1, the translation of 2 units down. Question 5, using the information given below, which set of triangles cannot be proven similar? So let's write out all of the proofs for congruent triangles. So you have SAS, then you also have angle, side, angle, 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 side, and finally you have side, side, side. There is one proof that is explicitly for similar triangles. And that proof is angle, angle, which by extension is angle, angle, angle. I forgot to mention that with the congruent, there is one more, hypotenuse leg, but this is only for right triangles. And another thing to keep in mind, that all congruent triangles can be proven similar, but not all similar triangles are congruent. So let's see what we have here with choice 1. We have SAS, because we have a side, an angle, and a side in both cases that are proportional. So in this case, we can say that 1 can be proven similar because these factors are similar. In fact, they're directly proportional. For choice 2, it looks like we are given 2 angles that are congruent. This applies to the angle-angle similarity proof. So SAS, that's for 1. This is for 2. Actually, hold on, I should probably put that here. And choice 3, we have what looks like a side-side angle. Keep in mind that that does not prove similarity nor congruence. I remember back in high school, my geometry teacher used to joke that if you flip this word around, then you would get a very naughty word. And that's how you remember that it is not a valid proof for congruence or similarity. So we can eliminate choice 3, or rather we can uneliminate choice 3 because we can't use this information alone to prove the triangles are similar. And that leaves us with choice 4. That is another side angle side. However, because both sides are being shown as congruent, then you can directly prove that they are the two triangles are both congruent. So because of that, the only one we can eliminate is choice 3. So that means that just based on this information, the third set of triangles cannot be proven similar. Okay, let's go on to question 6. A company is creating an object from a wooden cone with an edge length of 8.5 centimeters. A right circular cone with a diameter of 8 centimeters and an altitude of 8 centimeters will be cut out of the cube. Which expression represents the volume of remaining wood? So you know what we have to do. We have to draw this out on the right side of the screen. I know it's not perfect, but it's art, all right. So I'll use a different color. So I'm going to use red to represent the negative space. There we go, that looks a lot better. So let's add in our measurements. Whoops. We have 8.5 centimeters. With the cone, we have a diameter of 8 centimeters. And we also have an altitude of 8 centimeters as well. So the formula for the volume of the cube is V equals S cubed. That is pretty straightforward. But the V for the cone is equal to 1/3 times pi times the radius squared times the height, which in this case is the altitude. And let's fix this. So the net volume is equal to the volume of the cube, and we're subtracting the negative space that's cut out from this cube that's represented by the cone. So the volume for this is equal to 8 centimeters cubed. Actually, 8.5 centimeters cubed, excuse me. And in this case, they're asking for the radius of the cone. This problem only gives the diameter. Now this is thankfully very easy because the radius is just equal to 1/2 the diameter, and 1/2 times 8 is 4 centimeters. Sorry, that doesn't look the best. Which in this case, you plug in, you get 1/3 pi times 4. Actually, I'll put it under parentheses to just make it look a bit better, but mathematically it doesn't make a difference, times 8. So in this case, the V net is equal to oh shoot, I forgot the units for the V cone. So sorry, I'm a perfectionist. I'm just gonna move the caret back. Actually, the position of the caret does make a greater difference in something called dimensional analysis, which I will touch on later. Just adding that space to make it look a bit visually better. And this should be the final expression you get for the volume. And this is equivalent to choice 4. I hope that my explanation cleared it up. We're going to move on to the next question. Two right triangles must be congruent if so this is a question about the properties of triangles. You know that two right triangles must be congruent if the corresponding legs are congruent because of the SAS being congruent to SAS congruence proof. In this case, the corresponding legs would be the side, and because it's a right triangle, you know that the central angle is always going to be 90 degrees. So if you have two triangles and you can prove the corresponding legs congruent, then these two are congruent. So the correct answer is choice 3. Okay, 8. Which sequence of transformations will map triangle ABC on the triangle A prime B prime C prime? So right off the bat, we know that because A prime B prime C prime is physically larger than triangle ABC, we know there has to be a dilation. So right off the bat, that eliminates 1 and 2. We know that there also must be a rotation because in order for A and B, or line segment AB, line segment BC, and line segment CA to all be parallel to their prime counterparts, they have to be rotated. There's no way to make, let's say, line segment AC parallel to line segment A prime C prime by rotating alone. So, or just translating alone, excuse me. So in this case, we can also eliminate 3, and that leaves choice 4, dilation and rotation. Let's move on to question 9. In parallelogram ABCD, diagonals AC and BD intersect at E. I'll draw this out. So we know this is the parallelogram, so let's draw some of the properties that we know have to be true. We know that opposite sides are parallel to each other. We also know that opposite sides are congruent to each other. So we have two sets of congruent sides. So let's go over each statement and determine if we can prove that parallelogram ABCD is a rhombus based off of them. If AC is congruent to DB, that means that these two diagonals would be congruent, and we know that that is not a property of rhombuses. Rhombi, I should say, do not have congruent diagonals, and that's because with the rhombus, the physical geometry of the shape makes it that one diagonal is always longer than the other. So that eliminates one from proving the parallelogram ABCD is a rhombus, but let's go over the other ones. Going back to one real quick, if you had a shape, a parallelogram, with equal diagonals, congruent diagonals I should say, then that'll mean either you definitely have either a rectangle or a square. You can get a square from transforming a rhombus in such a way that its diagonals are equal, or you can get a square by making sure a rectangle, which already has congruent diagonals, has congruent sides as well. So the second choice, line segment AB is congruent to line segment BC. That would make this a rhombus because the definition of rhombi is that all of their sides are congruent with each other. They're equal in length. So we can eliminate that because we can prove ABCD is a rhombus. Choice 3, segment AC is congruent to segment DB. Once again, that's a property of rhombi, that they have perpendicular diagonals. And choice 4, segment AC bisects segment DCB. Once again, that is a property of rhombi. That's also a property of squares, but not necessarily the case for rectangles. So that leaves us with choice 1. That segment AC is congruent to segment DB, because if it were true, then that would make this a rectangle instead of a rhombus. Going now to choice 10. In the diagram below of circle O, segments OB and OC are radii, and chords AB, BC, and AC are drawn. Which statement must always be true? So in this is a property of radii and circles. In fact, specifically, it's a property of inscribed angles. We know that for this arc length, I'll call this angle X. We know that because O is at the center and OB and OC are radii, O inscribes the same angle as the angle inscribed by the arc of X. And we know that because A touches the circumference of the circle, we know that it has to inscribe an angle that is 1/2 of this angle X. So therefore, statement 2 must always be true. Going to question 11. A 20-foot support post leans against a wall, making a 70-degree angle with the ground. To the nearest tenth of a foot, how far up the wall will the support post reach? I'll draw this on the right side. There's your wall. There's your ground. Here is the support post. Now the length of the post is 20 feet. And we want to know how far up the wall will the support post reach. In this case, it's asking for the vertical distance that this post makes with the wall. And we know that this angle is 70 degrees. And that's because the question told us that. Now, the appropriate trig function to use here is sine. We know that in this case, the sine of an angle is equal to the opposite side over the hypotenuse. And if we rearrange this to solve for x, you get that x equals 20 times sine of 70 degrees. The degrees is important. Make sure your calculator is in the right mode. Mine is. And plugging this into our calculator, we get 18.79385 so-and-so feet. This is asking to the nearest tenth of a foot, so we have to round this. In this case, because the hundredth number is an x, or is a 9, that means that x rounds to 18.8 feet. So therefore, the correct choice is question 4. Or the correct choice is choice 4. Now we're going to move on to question 12. Line segments. The line segment NY has endpoints n of minus 11 and 5, and y at 5, minus 7. What's the equation of the perpendicular bisector of NY? Now you could graph this. In this case, I'm not going to, but I will write out the important formulas to use. So the midpoint is equal to and this will spit out a coordinate. Slope is equal to change in y over change in x. You may also see this represented by delta y over delta x. That's more common in higher level math classes. Either way your teacher presents them, keep this in mind. And this will spit out a number. So the reason we need both of these formulas is because we need to find the slope of line segment NY. And the reason we need to do this is because the perpendicular bisector will bisect line NY at its midpoint. And we need the slope because the slope of the bisector is the negative reciprocal of the slope of line segment NY. So let's do our calculating. If you plug this in this case, x1 is -11, x2 is 5, y1 is 5, and y2 is -7. This is equal to 3, -1. That's the coordinate of the midpoint. Now let's repeat this with the slope. y2 minus y1 over x2 minus x1. So -7 minus 5 divided by 5 minus -11. That's equivalent to adding 11. And you will get that this slope is equal to -3/4. Therefore, the slope of bisect, this is the slope of NY, by the way. So the slope of bisector is equal to 4/3. Now, one more thing that you should know is called the point slope form of a line, and that is y minus y naught equals m times x minus x naught, where in this case m is the number of the slope, and that is how the lines are being represented as the perpendicular bisector equation. So in this case, x naught and y naught are going to be the coordinates of the midpoint. The slope of bisector will be m. So our final equation will be y plus 1 equals 4/3 times x minus 3. And we're going to add 1 because it's the same thing as subtracting -1. So this is your final equation, and this is identical to choice 1. Hold on. That's sorry about that. I made a mistake. Mistakes happen all the time. This should be -3, -1. And this is equal to choice 1. Okay, sorry about that mistake again, but we're going to move on to question 13. In triangle RST shown below, altitude SU is drawn to line segment RT at U. If SU equals H, UT equals 12, and RT equals 42, which value of H will make triangle RST a right triangle with angle RST as a right angle? And if you do this, the key is to utilize the proportionality of the triangle system. In this case, drawing this will make the smaller triangle proportional to the larger triangle as a whole. This isn't something I see represented too well by math teachers, so I will actually draw the two triangles that I'm talking about. Now keep in mind that obviously I'm just representing these at the same scale for artistic license, but if they were the same scale, they would be congruent, but you can visually tell that they are not congruent because they are obviously different sizes. So our first triangle is triangle RST, or not triangle RST, triangle SUT. Our second triangle is triangle RST. And we see that both these angles, SUT and RST, are right angles. Now the system is proportional, so we know that UT over SU equals SU over RU. Now we want to solve for h, which is the height. In this case, whoops, sorry for making so many mistakes, but we can represent the same segment in two different triangles that are similar. And let's plug in the values we have into this diagram. So UT is 12 and RT is 42. That must make the length of RU 30, because 30 plus 12 equals 42. Let's draw this in here. We're also going to represent this, now that we have our full system of numbers in. 12 over h equals h over 30. If you rearrange this to solve for h, that is multiply both sides by 30h. You will get that h squared equals 360. And that makes h equal to the square root of 360. And a property of square roots is that the square root of a times b equals the square root of a times the square root of b. So doing that, you can separate this into the square root of 36 times the square root of 10. The square root of 36 is a good number to factor out because that's equal to 6. So therefore, we get that h is equal to 6 times the square root of 10. And that makes choice 2 the correct choice. Moving on to question 14. In the diagram below, triangle ABC has vertices at A 4, 5, B 2, 1, and C 7, 3. What is the slope of the altitude drawn from A to BC? Now you know that the definition of an altitude is that it is perpendicular to the side opposite to which it is drawn. And because of that, like in the previous example with question 12, we know that the slope of the altitude has to be perpendicular to the slope of the original line segment, in this case segment BC. So this is the same equation we used last time. Slope equals y2 minus y1 over x2 minus x1. And this is going to be for the slope of BC. Plugging that in, y2 is equal to 3 from C, y1 is equal to 1 from B, x2 is equal to 7 from C, and x1 is equal to 2 from B. Plug that in, and you get that the slope is equal to 2/5. So that makes the slope of the altitude equal to -5/2, and that makes the correct answer choice 4. So moving on now to question 15. In the diagram below, triangle ERM is similar to triangle JTM. Which statement is always true? So the way in which we have to do this is recognize that for a system of these triangles, we know that based on angle, angle, and in turn angle, angle, angle similarity, that these angle measurements will always be congruent to each other. Or they will always be equal to each other. So the best way that I can think of to solve this question is just to write out each of the trigonometric relations for each triangle. So in this case, we have that cosine of J is equal to Jm over Tj, but we know that because angle E is equal to angle J, and cosine is a function of an angle, and that means that cosine E must be equal to cosine of J. Cosine of E is equal to ME over RE. Let's repeat this again for the second option. Cosine of R is equal to MR over RE, or no, equal to TM over TJ. That's literally based on never mind, I had it backwards. Sorry about that. Cosine of R is equal to RM over RE. This is also equal to cosine of T, which is equal to TM over TJ. Let's do this again for the third option. In this case, we have tan of t is equal to Jm over Tm. But we know that this is also equal to tan of r, which is equal to me over rm. And one more statement is with the fourth, tan of e is equal to rm over me, but it's also equal to tan of j, which is equal to tm over jm. Whoops. So putting this all together, we have to look at each of the options and see which one of these has a statement that matches what we wrote. In this case, we can eliminate choice 1 because in this system, cosine of j is never equal to rm over re. We can also eliminate choice 2 because cosine of r is never equal to jm over jt. Similarly, for choice 3, we never have that tan of t is equal to rm over em. But for choice 4, we have that tangent of e is equal to tm over jm. So therefore, choice 4 is the only statement which is always true. Let's move on now to question 16. On the set of axes below, rectangle ABCD can be congruent to rectangle KLMN using which transformation? Now, you can think of the name in this case. The name of the points are the points that correspond to each other. And to get the points to match up with each other, you have to perform a mapping that maps each one of the points in the name to their congruent partner. So A to K, B to L, C to M, and D to N. And from the looks of it, the only choice that satisfies this will be reflection over the x-axis. In this case, it's easy to draw the translations on the graph itself. So we have A to K, we have, in this case I have it backwards, whoops, D to N, we have B to L, and we have C to M. And this will be achieved through the correct choice, which is choice 3. Reflection over the x-axis. Let's move on now to question 17. From the diagram below, D, B, and AF intersect at point C, and AD and FBE are drawn. If AC is equal to 6, DC is equal to 4, FC is equal to 15, the measure of angle D is 65 degrees, and the measure of angle CBE equals 115 degrees, what is the length of CB? So, right off the bat, let's solve for things. We know that because angles on the line sum up to 180 degrees, the measure of this has to be 65 degrees. That's because 115 degrees plus 65 degrees equals 80. We also know that these two angles are congruent because they're vertical angles. They're made by two intersecting lines. And that is enough to prove the similarity of these two triangles, ACD and FCB. And as we just showed, this is achieved through angle-angle similarity. Now, because this is the case, we can set this up as a system of proportional sides. Let's assign our unknown side length x, and we know that DC over AC is equal to BC, or CB, over FC. Now plug this in with numbers. Forget that 4 over 6 is equal to x over 15. And if you solve for x, you multiply both sides by 15. You get that x equals 60 over 6, which is equal to 10. So that makes the correct choice for this question choice 1. Moving on to question 18. Seawater contains approximately 1.2 ounces of salt per liter on average. How many gallons of seawater to the nearest tenth of a gallon would contain 1 pound of salt? So this is probably my favorite type of question in all of mathematics because it uses my favorite skill, which is dimensional analysis. For those of you that go on to take chemistry and physics, dimensional analysis is greatly important. If you know how to do dimensional analysis correctly, it makes solving questions so much easier. So the way that I tell all my peers to think of dimensional analysis is that dimensional analysis is a game of cancellation. The objective is to cancel as many units as you want by multiplying and dividing various fractions until you're left with only the units you want. So in this case, another ratio that we are given at the very bottom, at the very back of this test, is that 1 gallon is equal to 3.785 liters. That's on the formula sheet that's given to all students. We also know that 1 pound is equal to 16 ounces. That is also given as part of the formula sheet, but for anyone living in the United States, hopefully it's common knowledge. So the first thing to do is, if we're solving for gallons, we should start with what we know. We know that this amount of gallons has to have 1 pound of salt. Now, the first thing we're going to multiply is to cancel out that pound. We're going to plug in our prior ratio of 16 ounces to 1 pound. Then we're going to multiply that by what's given to us in the question, which is for every 1 liter of seawater, there is 1.2 ounces. Then we're going to multiply this yet again by the final conversion factor we need, which is 1 gallon for every 3.785 liters. Now, the reason I did this in this particular order is because we are sequentially canceling units with every factor we add. So the first unit we cross out are the pounds. The second unit we cross out are the ounces. And finally, the unit we cancel out last are liters. And that leaves us with only gallons. Keep in mind, when you're doing these cancellations, you don't touch the numbers. You only try to cancel the units themselves. So all of these fractions are inputted the exact same into your calculator as they are drawn out. So in your calculator, you would multiply 1 times 16 over 1 times 1 over 1.2 times 1 over 3.785. And if you do this and round to the nearest tenth of a gallon, as requested by the problem, you get 3.5 gallons, which is equal to choice 2. Oops, wrong choice 2. This is the correct choice 2, 3.5 gallons. Let's move on once again to question 19. Line segment EA is the perpendicular bisector of segment ZT, and segments ZE and TE are drawn. Which conclusion cannot be proven? So let's consider what a perpendicular bisector represents. That because it's a bisector of ZT, we know that ZA is congruent to TA. We also know that these are right angles. So let's do this question conclusion by conclusion. So choice 1, EA bisects angle ZET. So we can use something called the reflexive property to set EA congruent to itself, and we can use the side angle side congruence proof to prove that triangle EZA is congruent to triangle ETA. Because of this, we know that if triangles EZA and ETA are congruent, then based on CPCTC, we can prove these two angles as congruent, angles ZEA and TEA, and this will prove conclusion 1 correct because EA bisects angle ZET to create two congruent angles. That is the definition of a bisector. So we can eliminate choice 1. Now let's move on to choice 2. Triangle EZT is equilateral. So using the CPCTC, we can also prove that these are equal. They are equal in length. So sides ZE and TE, are congruent. But based on this information alone, we cannot prove that sides ZE or TE are congruent to sides ZT. And that means that for the time being, we cannot prove the triangle EZT is equilateral. Now, once again, let's move on to the next conclusion. EA is a median of triangle EZT. And the definition of a median is a line that is drawn in a triangle from a vertex to the middle of opposite side. And in this case, we know that EA is a median because we proved that EA is the perpendicular bisector of ZT. In fact, it's given to us in the question. We didn't even need to prove it. Based on this, we can tell that EA is a median. It's drawn from vertex E and bisects segment ZT. So that makes it a median. Going on to the final conclusion, angle Z is congruent to angle T. Once again, this can be proven using our best friend, CPCTC. So that one is straightforward. So that leaves us with only conclusion 2 as the one that we cannot prove with the information we are given. Okay, moving along to question 20. A hemispherical water tank has an inside diameter of 10 feet. If water has a density of 62.4 pounds per cubic foot, what is the weight of the water in a full tank to the nearest pound? So the first thing we should do is draw this out. I'll draw it on the right side. Whoops. Let's say it looks even. Whoops. I can't get it. I know what I'll do. Here we go. There's my best attempt of erasing this with the way that my system will recognize. So a hemisphere is half of a sphere. I barely even made a difference. You also have to use your imagination. Imagine that the bottom half of this is fully erased so that no one can see it. It doesn't exist. There we go. Oops. That's the easy solution. Just use squares to cover it up. And the volume for a regular sphere is equal to 4/3 times pi times r cubed. But in this case, the volume of our hemisphere is 1/2 of that. And this can be simplified to 2/3 times pi times r cubed. Now that we have this, we can plug in what we know. Let's first represent it on the diagram. So the inside diameter, the inside diameter is 10 feet. That makes the radius equal to 5 feet, because the radius is half the diameter. So the volume that we want is equal to 2/3 times pi times 5 feet cubed. We get that this volume is equal to 261.799 cubed. Now, in this case, we know that we want the weight of the water, which is equal to pounds. So we're going to represent this by another dimensional analysis, which we have our volume of foot cubed times pounds per foot cubed. Which, if you recognize the units, is equal to our density. I'm using W to represent the weight. This weight is equal to 261.799 feet times 62.4 pounds per foot cubed. And if you plug it into your calculator and round it properly to the nearest pound, you will get that the weight is equal to 16,366 pounds. So we can safely assume that the weight of the water in this tank is equal to choice 1. Moving on to question 21. In the diagram of triangle ABC, points D and E are on segments AB and CB, respectively, such that AC is parallel to DE. If AD is equal to 24, DB is equal to 12, and DE is equal to 4, what is the length of segment AC? So this one is a fun one. So based on the relationship described in the problem, know that these are parallel. And therefore, these angles, angle C and angle E, will be congruent with each other. Same thing for angle A and angle DEB. Sorry if that's a bit cramped. And angle B is congruent with itself. So these two triangles are similar through angle-angle similarity. So let's draw what is represented in the problem. In this case, I'm assigning x as the length we want, which is AC. Based on the proportionality of the sides of similar triangles, we know that DB over DE, so part over whole, equals AB over AC. We know that AB equals AD plus DB (24 plus 12) equals 36. So representing this mathematically, you have 12, whoops, it's a bit big, 12 over 4 equals 36 over x. If you multiply both sides by 4x, you will get that 12x is equal to 144. This makes x equal to 12. And therefore the correct choice is choice 2. Moving on to question 22. The triangle RST is graphed on a set of axes below. How many square units are in the area of triangle RST? This was one of the more difficult questions, but one of the key inclinations that you should know is that a triangle will inscribe an equivalent area of 1/2 of the parallelogram that it cuts in half. So in this case, I just drew out the full parallelogram. I should use a different color other than black. It may be confusing, but there it is, drawn out in full. So how many square units are in the area of triangle RST? So let's write out the points and their coordinates. We have R at -2, 7. We have S at -5, 1. And we have T at 7, -5. And in this case, we'll need to use the distance formula. This is actually a rearrangement of the Pythagorean theorem. If you sit down and think this one out, basically you're solving for the long leg of a triangle, which is located on the Cartesian coordinate system, where you know the length of the other legs as the differences in x and y respectively. So that's another useful intuition. And in this case, we need to figure out the distance of RS and ST. The measure of the segment RS is equal to Oops, I'm going to draw the square root in by hand. I can change this as well. There we go. So in this case, x2 is -5, x1 is -2, but it's being subtracted, so it's the same thing as adding it. And y2 is 1 from S, and y1 is 7 from R. If we plug this into our calculator, we will get that this is equal to radical 9 plus 36 equals radical 45. Whoops. Now let's repeat what we did, but with the measure of ST. And in this case, you're going to plug in these numbers. In this case, 7 is our x2 from point T, 5 is our x1 from point S, but it's being subtracted, so we're adding it here. And -5 is our y2 from point T, and -1 is our x2, no, y1 from point S. It's being subtracted, so that's why we're making it a negative number. And this, in turn, is equal to radical 144 plus 36, which is equal to radical 180. So now we have that. When the area for a triangle is equal to its base times its height, the area for a parallelogram, is equal to its base times its height. The area for a triangle is equal to 1/2 times its base times its height. And in this case, we have ST as the base of the parallelogram and RS as the height. In fact, another way to think of it is if you rotate your head so many degrees, then you get a rectangle where ST is the horizontal side length and RS is the vertical side length. And in that case, it's just length times width, just like you probably know from elementary school, or even in the womb. So that the area is equal to radical 45 times radical 180 times 1/2, because we're only calculating the area of this triangle, not the whole parallelogram. 1/2 base times height. And we get this is 1/2 of radical 8100 is equal to 1/2 times 90, which is 45. And this is equal to choice 3. So that settles this question. Now, 23 is probably, in my opinion, the most difficult question in this entire exam, at least for the first part. Now, the key intuition, and I'll explain what you should be doing once I read the question. The graph below shows segment AB, which is a quarter circle O. The coordinates of the endpoints of segment AB are A at 3, 3, and B at 3, -7. The distance from the midpoint of AB to the center of circle O is 2 units. What could be a correct equation for circle O? The difficulty here is that there are 2 correct possible variations of how you draw your circle. So we could go over the whole formula of finding the midpoint from just the coordinates alone, but I'm going to take a shortcut because this is supposed to be multiple choice. And I'm just going to mark where the midpoint of this line is. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the vertical line, 10 units long. So halfway through would be 5 units. Let's count down 1, 2, 3, 4, 5. And the distance from the midpoint of AB to the center of circle O is 2 units. I'll draw one of the midpoints, one of the centers in circle O, blue, and the other in green. So this is the shortest possible distance of 2 units, because this is the perpendicular line. And if we draw it as a circle, the circle that we get, sorry it's not perfect, but the circle that we get, the center is to the right of the line. That's a chord. Now if we draw this with a different color, in this case I'm going to use green. Whoops. Sorry about that. We duplicate this. No, I think we'll have to draw a fresh circle. So continuing on this, So this is a circle which is identical in measure, but in this case, it has a midpoint, which is 2 units to the left of the center of the chord. What could be a correct equation for circle O? Now, one thing we do have to figure out is we do have to figure out the distance of the radius. And that can be done using trigonometry. So we know that if the length of the line is 10, and we're dividing it at its midpoint, then that means that the length of this side has 5. The length of this side is 2. And using the Pythagorean theorem, x squared is equal to 29. That means that x is equal to the square root of 29. Now the form of the equation that we need to use is, I forget the exact name of it, but writing it out, it's x minus h squared plus y minus k equals r squared, where hk is the circle center, r is the circle's radius. Now we know that visually, looking at the blue circle, hk is equal to 5, negative 2, and the green circle equals 1, negative 2. Now going back to these choices, we can easily eliminate 3 and 4 because we know that r squared is equal to x squared, which we solved and got 29, so it can't be 25. We know that if we plugged this form in for the blue circle, we would get that x minus 5 squared plus y plus 2 squared equals 29. If we did the same thing for the green circle, we get that x minus 1 squared plus y minus 2 squared equals 29. Whoops, that should be a plus 2. So the only one of these choices that matches is therefore choice 1. In this case, it's the equation for the green circle, which is to the left of the midpoint of the chord. Let's scroll down to question 24. What is the area of a sector of a circle with a radius of 8 inches and formed by a central angle that measures 60 degrees? So in this case, the formula is equal to Now this is the case for degrees. If you had it as radians, then the bottom 360 degrees would be replaced by 2 pi radians. The formula for the area is equal to theta over 360 times pi r squared. Let's solve for this. If we plug in the numbers from our problem, we get that A is equal to 60 degrees over 360 degrees times pi times 8 inches squared. Oops. Which simplifies to 1/6 times pi times 64. A is equal to 64 over 6 times pi, which is equal to 32 over thirds times pi. And in this case, we will get choice 3 as the area of the sector of the circle. So that concludes the first section, multiple choice. Now going on to the second part. 25. Describe a sequence of transformations that will map triangle ABC on the triangle DEF as shown below. Looking at visually, if we want everything to line up, the first thing that we should do, there are multiple possible correct transformations. I'm just going to describe the first one that came to mind to me. So let me make this triangle here. So the two transformations that achieve this change in coordinates, the first one is translation, 6 units to the right, and the second, second transformation is reflection about the x-axis. This will map point A onto point D, point B onto point E, and point C onto point F. So that's fairly straightforward. Point P is on segment AB such that the ratio between AP, PB is 4:5. If A has coordinates 4, 2, and B has coordinates 22, 2, determine and state the coordinates of P. So I'm only going to bother with finding the distance in one dimension because based on these coordinates, we know that AB is a horizontal line. That the y measurement of A is the same as the y measurement of B, so therefore there is no change, there is no rise in the y direction. So using our distance formula from below, get the measure of AB equals minus 2 squared plus 22 minus 4 squared. In this case, the 22 comes from the x-coordinates of B, and 4 is the x-coordinate of A. Doing this and plugging this into your calculator will get that radical 18. whoops, actually, there shouldn't be a radical under that. We know that if this ratio is 4 to 5, then that means that point P and this simplifies to 4/9. Let's just represent this visually really quickly. Keep in mind that this is not the scale. If this length is 4 and this length is 5, so AP is 4, PB is 5, then the length of the entire line will be 9. So therefore, point P is 4/5 or 4/9 of the way along the line. 4/9 divided by 5/9, you will get, now if you, sorry, that's the wrong way of looking at it, 4 over 4 plus 5 will get you 4/9 of the way along the line, and 4/9 times 18. We can simplify this, cross that is 2, this can be 1, and we'll get that the point is equal to 8. This is the x-coordinate of the line, so in conclusion, P has coordinates of 8, 2. Going down to question 27. In triangle CED as shown below, points A and B are located on sides CE and ED respectively. Line segment AB is drawn such that AE is equal to 3.75, AC is equal to 5, EB is equal to 4.5, and BD is equal to 6. Explain why AB is parallel to CD. So with dilations, you want to think of this as part over whole. If you can prove that the part to whole ratios of corresponding sides are equal to each other, then therefore they must be similar triangles. So in this case, we have length EC as our whole length and EA as our part length. And likewise, we have ED as our whole length and EB as our part length. We know that this is equal to 8.75, which is just 3.75 plus 5. This is equal to 10.5, which likewise is 4.5 plus 6. And we should be able to prove that EA over EC is equal to EB over ED. And I'm going to represent this as part of 1 over whole 1 equals part 2 over whole 2. So it's 3.75 over 8.75 equal to 4.5 over 10.5. If you plug both of these fractions into your calculator, we'll find that yes, they are equal. So therefore, these triangle CED is similar to triangle AEB. Whoops. So explain why AB is parallel to CD. So we have proven actually, we haven't quite proven this to be Oops. I should erase this. I'm jumping the shark. That's the wrong expression to use, but I don't want my video being taken out for another reason. This eraser won't work. Sorry about that mistake, but this alone has proven that triangle AEB is a dilation of triangle CED. If you want to prove that they are congruent, then we know that we can set this as congruent, and because we have two proportional sets of sides and an angle which is congruent to itself, we have triangle CED is similar to triangle AEB. Because of this, you can also extend this, saying that the other sets of angles are congruent. So that AB is parallel to CD, because the inscribed angles created by the two lines I should rewrite this because the angles created by AB is parallel to CD. AB is parallel to CD because triangle CED is similar to AEB. AB must be parallel to CD in order to create congruent angle pairs that are intersecting with sides EC, CE, and ED. We draw in the symbols. So So my reasoning is that since we've proven these triangles similar, these two sides have to be parallel so that the angles created at EBA and EDC are congruent to each other, because parallel lines, or an angle that crosses two parallel lines creates a pair of congruent angles, and the same thing is repeated with the other set of angles on the other side of the triangle. So therefore, we've proven that AB is parallel to CD. Okay, question 28. Find the value of r that will make the equation sine of 73 degrees equals cosine of r true when 0 is less than r is less than 90 degrees. Explain your answer. Now this is a trigonometric setup, so we're going to draw the first thing that comes to mind when we think of a trig function, a right triangle. So this isn't to scale, this is just to make drawing easier, but let's call this angle 73 degrees. This is our 90-degree right angle, and this is our other angle r. And in terms of this angle 70 degrees, we're going to call this our home angle. Because relative to this angle r, this side is the opposite side, this side is the adjacent side, and this is the hypotenuse side. Sine of 73 degrees, we can represent this as O over A. Now, whoops. How does it be? O over H. Now looking at this R, we know that cosine of R is also equal to O over H. This isn't the same thing as the SOHCAHTOA sides, but rather the names that we've given to these sides based on the position of our home angle at 73 degrees. So based on this, we know that sine of 73 degrees is equal to cosine of R. We can solve for R. If the interior angles of the triangle sum to 80 degrees, we've already got this 90-degree right angle, then we know that 90 equals 73 plus R. Solving for R will get you that R is equal to 17 degrees. The explanation that'll give, I'll move this up. So if we type this out, R must be the other non-right triangle angle to preserve for the side relationships of the trig functions, and the two non-right angles must sum up to 90 degrees. That is the same process that we used to work our way through this problem. So now already up to 29, the diagram below, circle 1 has radius 4, while circle 2 has radius 6.5. Angle A intercepts an arc of length pi, and angle B intercepts an arc of length 13 pi over 8. Dominic thinks that angles A and B have the same radian measure. State whether Dominic is correct or not. Explain why. So the most important formula to use is S equals theta R. can rearrange this. If we're solving for theta, you get that theta is equal to S over R. Just remember that theta is the angle in radians, S is equal to the arc length, and R is equal to the radius of the circle. So if theta 1 equals theta 2, S1 over R1 equals S2 over R2. That theta 1, just plugging it in, is equal to S1, which is pi, over R1, which is 4. And theta 2 equals 13 pi over 8. Divided by 6.5, which remember that dividing a fraction is the same as multiplying its reciprocal. We can further simplify this, because 13 is a multiple of 6.5 by a factor of 2, and 6.5 is a multiple of itself by a factor of 1, and we get pi over 4. The explanation is that Dominic is correct. Is the proportions of arc length to radius is correct, is equal for both circles. So the first thing we did was take this formula, rearrange it to solve what we were looking for, and then we solved it for both circles. We found that they're equal, and then we were able to state that Dominic was correct. Okay, question 30. A ladder leans against a building. The top of the ladder touches the building 10 feet above the ground. The foot of the ladder is 4 feet from the building. Find, to the nearest degree, the angle that the ladder makes with the level ground. So let's draw this again. Using a triangle, this is a classic trig setup. We know that if the top of the ladder touches the building 10 feet above the ground, this is 10 feet. The foot of the ladder is 4 feet from the building. This is obviously not the scale. I'm just making it easy to draw. This is our right angle, because hopefully, if the person built it correctly, then the wall of the building is proportional to the ground. We have to find, to the nearest degree, the angle the ladder makes with the level ground. We're going to call this x. And based on our trig relationships, tan of x is opposite over adjacent, which is 10 over 4. But we also know that arctan is our inverse function, that the arctan of 10 over 4 is equal to x. Now you may see this represented by a different looking function, whether it be on your calculator or the way your teacher writes it, as tan with a -1 superscript of x. They're mathematically the same, just different ways of writing it. So if you plug it into your calculator, you will get that this is equal to 68 degrees if you round it properly. So moving on now to question 31. In the diagram below, radius OA is drawn in circle O. Using a compass and a straight edge, construct a line tangent to circle O at point A. Now this is difficult to show in a digital format, so first I will write the steps that I'm doing, and then I will attempt to draw them out. So step 1 is to extend line OA. Step 2 is to mark another point. For step 3, step 4, we're going to repeat the same thing. The little symbol, by the way, with the 2 dots, if you don't know, is just representing carrying this over. But we're going to make a modification. We want to make sure that we don't change the radius in between the steps. And finally, our 5th step, we're going to draw a line between the points of intersection of the radii that we drew in the previous steps. So what does this mean? Well, our first step is to extend this line. The second step is to create a circle. Actually, I'll use different colors for the different steps. The next step is going to be blue. From point O, construct a circle with a radius of any distance greater than OA. I have to finish the second step. Sorry about that. This is our point B. Let's rinse and repeat with the 4th step. In this case, we're going to use yellow. Actually, that may be difficult to see. I'm going to change it to light green. Let's I don't think it's possible to directly copy objects with the software I'm using. Just going to use my best to approximate it. Same size. We're going to center this at our point B. Our final step, which is point 5, we're going to use a purple color for this. We're going to mark these 2 points. Call them C and D. And we have to finally draw a line between them. And we get the best possible tangent line I can draw. So if you're doing this on paper, I don't think you need to write out all of these steps. I'm only doing it because that's what's easiest to do on a computer. But moving forward to question 32. A barrel of fuel oil is a right circular cylinder where the inside measurements of the barrel are a diameter of 22.5 inches and a height of 33.5 inches. There are 231 cubic inches in a liquid gallon. Determine and state to the nearest tenth the gallons of fuel that are in a barrel of fuel oil. Whoops, so I'm still using purple, I'll use black. So there's our barrel of fuel oil. So let's write out the measurements we have. This is 33.5 inches. And we have a diameter of 22.5 inches. And we know that the radius is half of the diameter. So we can actually just draw it right underneath it. This is going to be 1/2 times 22.5 inches, which is 11.25 inches. We know that the formula for the volume of a cylinder is 1/2 times, pi times r squared times height. And in this case, volume is equal to pi times 11.25 inches. That's going to be squared, by the way, times 33.5 inches. And we get that this is equal to 13,319.86 inches cubed. Now we have three-dimensional analysis again, my favorite thing in the world. And in this case, the units that we are able to cancel out are inches cubed. And we are left with only gallons. Plugging this into your calculator and rounding this appropriately will get you 57.7 gallons. So that is the answer for question 32. Moving on to question 33, proofs. Our first proof of the entire exam. Given parallelogram ABCD, line EFG, and diagonal DFB, prove that triangle DEF is similar to triangle BGF. So you know what to do. Let's make a 2-column setup. There's statement and reason on opposite sides. So statement 1 So this is, in my opinion, the easiest of the steps, and that is literally stating the obvious. State your givens. Now the strategy to this is, if we want to prove that triangles are similar, we have to think about how can we prove a triangle similar, and what can we show in our shape to get that such parts are similar. So one thing that immediately sticks out to me is, if we want to prove triangle DEF and BGF similar, we can start with one of the angles, in this case angle F, DFE, and GFB. And the reason we can do this is because vertical angles are congruent. Now, keep in mind that one of the ways that you can prove triangles as similar, which is what they're asking for, is through angle-angle similarity. Now, the best course of action would be if we can prove angle ADB and angle CBD as similar. But we can't just state that yet. We have to set it up so that we can prove it. So if you recognize these are alternate interior angles. There is the line, which is diagonal DFB, and it makes an intersection with these lines. And if we can prove that AD and BC are parallel, then we have created the alternate interior angles needed for our similarity. So the first thing we need to do is to prove line AD and BC as similar, and whoops, I accidentally triggered Discord there. Line 3, AD is parallel to BC, and we know this because opposite sides of a parallelogram are parallel. So that now that we've done that, in our fourth step, we can prove that angle ADB is congruent to angle CBD. Not sure how often I should be saying this, considering it's YouTube and they will demonetize anything under the sun if it contains reference to something that they don't agree with, which might be a bit dicey, but it's in the name of math. And the reasoning for this is that alternate interior angles are congruent. We have this. We have our fifth and final step, which is that triangle DEF is similar to triangle BGF. And the reasoning that I'm going to give is that angle-angle similarity. This is a very straightforward proof. It's not too difficult. It just requires thinking things out, recognizing what you need to prove both triangles are similar, and then creating the conditions from what you are given to make it so that the angles line up. So that is how you take care of question 33. Going on to question 34. In the diagram below, triangle A prime, B prime, C prime is the image of triangle ABC after a transformation. Describe the transformation that was performed. So it looks like this is very obviously a dilation, but more specifically, what's dilation factor? We can visibly look and see that the length of AB is 8, the length of A prime B prime is 20. Dilation factor is equal to 8 over 20. Actually 20 over 8, sorry, which is equal to 5/2. Now, where is the origin of this dilation? Where is the dilation point? And it looks like it is the origin. And the reason I can tell is that I want to draw these lines in red. If you draw a line that goes through each point in its dilated counterpart, then they all intersect at the origin. So based on this, we know that triangle ABC was dilated by a scale or a factor, I'm just going to go scale, of 5/2 from the origin, which in this case is 0, 0. Explain why A prime, B prime, C prime is similar to triangle ABC. Now this is because dilation preserves angle measure the two triangles are similar to angle similarity, which in this case we can extend to angle similarity. So the dilation preserves angle measure. This means that the measure of these angles does not change as they're being dilated, and that means that these angles remain congruent. So therefore, through angle similarity, triangles ABC and A prime, B prime, C prime remain similar. So going on to the more difficult proof, we have to prove that ACD is an isosceles triangle and AEB is a right triangle. So I may have to extend this proof onto the right side. Hopefully we'll have to do that. Now, first thing we should do is list our givens. The reason for this is given. So the second thing we want to think about how we can prove ACD is an isosceles triangle. And we can do that by either proving that the angles of its base are congruent and equal to each other, or that the measure of the non-base sides are congruent and therefore equal to each other. So let's see what we can do. The first thing we can do, if we look at the parallelogram, we can prove that both sets of sides are parallel to each other. In this case, I'm going to compare sides AB and CD. But to do that, we need to define quadrilateral ABCD. Now, we know that this is the parallelogram because it's given to us that AB, AC, and BD are diagonals that bisect each other. Let's continue on to statement 3. Now we notice that we know that this is the parallelogram. We just defined it as a parallelogram. We could prove it as a parallelogram based on one of the statements that we were given. Now we can prove that AB is parallel to CD. And the reason for this being that opposite sides parallelogram are parallel. So if we, it looks like what we can do, it's probably easiest to work with the angles because we have defined that some of these angles are congruent. That's given to us. If AB and CD are parallel, then we know that angle 1 is congruent with angle ACD. And the reason for this is that alternate interior angles are congruent. Let's move now to, now if angle 1 is congruent with angle ACD, and angle 1 is congruent with angle 2, then with step 5, we can state that angle 2 is congruent with angle ACD. And the reason for this is the transitive theorem. The transitive property, more specifically, if A equals B and B equals C, then A is equal to C. So we've extended that to congruence. So now we can state, we have sufficient information to state that triangle ACD is isosceles. Now our reasoning for this is that isosceles triangles have two congruent angles at their base. So I will continue this on this side because we're going to prove the next thing. Here's our statement, here's our reason. Now if we want to prove that AEB is a right triangle, then let's think of everything we have. So we know that if this is an isosceles triangle, then we know that we can prove AD and CD as congruent. The reason for this is that isosceles triangles have congruent legs. Now, if we have a parallelogram that has two congruent sides, then we know that, by extension, ABCD is a rhombus. We know this to be true because our reason is that a parallelogram with adjacent sides which are congruent is a rhombus. Now, we know that one of the properties of rhombi is that their bisectors are perpendicular. Whether the diagonals are perpendicular. If you let me make that a bit clearer. AC and BD are perpendicular, reasoning being that rhombi have perpendicular diagonals. Our 10th statement is that AEB is a right angle, and this reasoning being that perpendicular lines form right angles, and our final proof, our final statement I should say, is that AEB is a right triangle. And the reason is that right triangles contain a right angle. So that is the very lengthy proof that satisfies both things that question 35 wants. We have started with a quadrilateral with some given things, and based on the given things, we have figured out what we need to prove to satisfy the conditions of the problem. So moving on to the final question of this exam, question 36. I remember back in high school, I called this the cone of doom. A water glass can be modeled by a truncated right cone, a cone which is cut parallel to its base as shown below. The diameter of the top of the glass is 3 inches, the diameter at the bottom of the glass is 2 inches, and the height of the glass is 5 inches. The base for the diameter of 2 inches must be parallel to the base with a diameter of 3 inches in order to find the height of the cone. Explain why. So the best way to explain this, I'll do it on the right side, is with cross sections. If you have a cone like this, and you have a rectangle that slices that cone in half, you will get a triangle as its base. And you can set this up as a system of similar triangles. So we're going to include this drawing in our explanation. The base with a diameter of 2 inches must be parallel to the base with a diameter of 3 inches to preserve the angle congruency of the corresponding angles within the cross-section. This results in angle-angle similarity. And then I'll add one thing to this. The proportion of the sides can be used to solve for the height of the cone. Whoops. So continuing 36, determine and state in inches the height of the larger cone. So let's do some math. So this is 3 inches, 2 inches. This height is 5. But this height we can represent as x. This will be 5 plus x. So once again, utilizing the proportionality of the sides for similar triangles, we can solve this as x over 2 equals 5 plus x over 3. Keep in mind that we are going to solve for 5 plus x is the height of the larger cone. That's how it's defined in the answer key. So if you multiply by 6 on both sides, you'll get that 6, you get that You get that 3x equal to 2 times 5 plus x in parentheses. 3x equals 10 plus 2x. Subtract 2x from both sides, and you get that x equals 10. X plus 5, therefore equals 15. Determine to the nearest tenth of a cubic inch the volume of the water glass. So we essentially have to find the volume of the small cone and the volume of the entire cone. I'll call it LC. The volume of the cone is equal to 1/3 times pi times r squared times height. The volume of the larger cone is equal to 1/3 times pi times 1.5 inches squared times 15 inches. And the 1.5 inches just came from halving the diameter of the larger cone, just its base. Oops. Here we go. There's the two radii. At the volume of the smaller cone, or this volume is equal to 35.343 cubic inches. Let's repeat this process for the smaller cone. Third times pi times 1 inches squared times 10 inches. And if we do this, you get that this is equal to 10.472 inches cubed. The volume of the larger cone minus the volume of the small cone equals 35.343 inches cubed minus 10.472 inches cubed. So therefore, the volume of the glass equals 24.9 inches cubed when you plug it into your calculator and round it to the proper length, which is the nearest tenth of a cubic inch. And with that, that concludes the solution of the June 2016 Common Core Regents exam. Those are all 36 questions, and I hope this guide helps you greatly.